Hello everyone, good morning. So in today's class we will learn strain and its types. Okay, so first of all, what is mean by strain? See, whenever we are applying some force on any object, there is change in its configuration. Change in its configuration means either it may change in its length, either it may be change in its shape, or either it may be change in volume. Then the ratio of that change in configuration divided by original configuration is nothing but strain. Okay, so let's see what is the strain. I'm writing here definition, how we can define this. The ratio of change in configuration what is meant by configuration? Yes, as I told, that is shape, maybe length, or else volume. Okay, to the original configuration. And therefore this strain is equal to change in configuration to the original configuration. Okay, understand? Okay, so this is what definition of strain, right? So see some examples I'm telling you. Now suppose there is a small rope, we can say, which is extensible, and now from this side you are pulling and this support is fixed, suppose, and this string or whatever this rope is there, it has elongated something delta L, and actual length of this string was L, then this is called longitudinal strain, and this is nothing but delta L by L, that is change in dimension by original dimension. So here it is length. Sometimes you may get in change in shape also, sometimes you may get change in volume also. According to that, the change in configuration to the original configuration is what your strain is. Now tell me, what will be the unit for this? That is, what is the SI unit for strain? Can anybody see? As these two are of same dimensions, we can say, because if we will take length, above it is what? Change in length by original length. If we will take shape, change in shape by original shape. If we will take volume, change in volume by original volume. So there is no any unit. This is unitless quantity. Which one? Strain. So here I am writing, it does not have any unit. It does not have any unit. Okay. Now let's see its types. So what are the types? Strain, we are going to learn only 3 types of this strain. So what are those? Let's see. You can note down simultaneously with me if possible, or else you can listen first and pause the video, and then also you can note down. Choice is yours. Okay. So first one is longitudinal. Which strain that is? First one is longitudinal. Longitudinal means change in length. Okay. Longitudinal. Next one is volume strain or shear strain. Let's take volume strain. Volume strain. And third one is shear strain. Third one is shear strain. Got it? So these 3 types we are going to learn now in detail. So let's move ahead. Finished writing? Okay. So let's see first one, that is longitudinal. First one is what? Longitudinal strain. Okay. So here LS means what? Longitudinal strain. Obviously longitudinal means what? Change in length by original length. Okay. So this is change in length by original length. Change in length by original length. So if suppose you are having this rod, okay, right, and let us suppose its length is L. How much is the length? L is the length. This is case 1. Okay, and after some time what we did, we have applied some force, and then this length has increased little. So how much it has increased? This much it has increased, which I have shown by dotted lines. So this is what? L plus delta L. Okay. Now this is how much? L plus delta L. Got it? There is some change in length. And if we will see this part is what? Delta L. So in this case, longitudinal strain, that is LS, is equal to what? Delta L by small l. Understand? It is very easy. Yes. Shall we solve one small problem? Okay. So let's see one small problem. Very easy. Very easy. Very ante very easy. చిన్న పిల్లల వస్తువు. Alpenlibe. Okay. So see what is the problem on this train. A steel wire 2 meter long. A steel wire 2 meter long is suspended from the ceiling. Is suspended from the ceiling when a mass is hung at its lower end. When a mass is hung at its lower end, the increase in length recorded is the increase in length recorded is 1 centimeter. Calculate strain or determine strain in the wire. Okay, right? This is what they have given. Now see here, suppose this is a ceiling and now a rod is hanged like this. This is a rod and some weight is hanged here. Okay, this is a weight, and because of this, what happens? There is some change in its length. So let us suppose this is a delta L, which it has changed. Okay, it will come down little, right? Okay, yes or no? So now strain is equal to what? Delta L by L. Now delta L is how much here given? 1 centimeter. How much it is given? 1 centimeter. So this is 1 centimeter, which is equal to 1 into 10 to the power of minus 2 meter. And L is equal to how much they have given? 2 meter. No need to convert. So direct use the formula and substitute this. 1 into 10 to the power minus 2 divided by 2. How much you will get? How much you will get? 1 by 2 means how much? 0.5 into 10 to the power minus 2. And now I am shifting this side. So you will get 5 into 10 to the power minus 3. What is the unit? Kilometer? No unit. Okay, it is unitless quantity. And which type of strain this is? Longitudinal. That's why I have taken below this longitudinal strain. Understood? How much easy? See? Easy. Easy means very easy. Got it? Okay. So let's see next one. First note down this. Note down this fast. Okay, finished. Right, let's move ahead. And the next type, that is, which one we have taken? Volume strain. Okay, so let's see the second one, that is volume strain. What is this second one? Volume strain. Now here, as you know, what will be there? Volume strain is equal to what? Change in volume by original volume. Yes. For example, suppose you are having a cube like this. And now you are applying force from all sides on this cube or of this cube. Then what happens? Its size will get reduced. Yes. Let us suppose this much small cube it is becoming. Can you see? Yes. So is there change in volume? Yes. Okay. So this cube will become small. And therefore volume strain is what? Delta V by phi. Original volume by change in volume by original volume. Right? Understand? This is what volume strain is. Shall we solve one problem? But it is very simple. Now you understood. I think no need also. Delta V, whatever it is, change in volume you just substitute, and original volume you will get it. Right? Okay. So here, how much pressure will be? This is initial pressure will be P naught and initial volume will be P, suppose. Okay. And here, what will be the pressure? P naught plus delta P, because you are applying some pressure, and therefore here phi is equal to how much? Final volume P naught plus delta P. So here shall I make it here P naught, right? Okay, that is nothing but P minus P naught is equal to delta V you will get, right? Change in volume means what? This is final volume is V, initial volume is V naught. Instead of V we will denote it P naught, and then V minus P naught is equal to delta V in this case. Got it? And then in this case, strain is equal to delta V divided by V naught. Okay, this is common formula, and this is what example which I have explained here. Nothing else, just change is what? Just initial volume we have assumed as a V naught, and final volume is V. Here this is just change in volume by original volume. So in word also I will write, that is what? Change in volume divided by original volume. Okay, this is what your volume strain. And third type, let's move ahead for third type, that is shearing strain. Third one is what? Shear strain. And this shearing strain is denoted by phi. How we are denoting? Like this. Wait. Like this. Understand? Phi. Now, what is the definition of this shearing strain first of all? This is equal to relative displacement between two extreme layers. Relative displacement between, shall I write down? Wait, that space is not sufficient. I will write below. One. So here I am denoting it with phi, and this phi is equal to relative displacement between two extreme layers. Relative displacement between two extreme layers divided by perpendicular distance between the layers. Relative displacement between two extreme layers divided by perpendicular distance between the layers. Okay, right? So how it is? Let's see. I will show you one diagram. Now see here. When we are applying force like this box is going to change its shape like this. And you see, this is what this delta x, I will denote with dotted lines. This is what? Because of this force. Okay, and this is what your perpendicular distance, that is L. है ना? This is perpendicular distance, and this is what L is. Capital L I am denoting. I am denoting with capital L. So this is capital L. And now whatever this is there, no, this one, this is nothing but your phi. That is called shearing strain. What is that? Shearing strain. And therefore in this, phi is equal to relative distance between two layers is what here? Delta x divided by, this is what? Capital L. That is what this length is. And this is your strain. Which strain? Shear strain. And this strain is due to what? Because of change in shape of the body. And this strain is due to change in shape. This we did, I think, so many times. You are taking a box, and at top edge, if you are pushing it, definitely its shape is going to change like this. And whatever that distance, and that particular distance, if you will take ratio, you will get that shear strain. Okay, understood? Understood. Shall we solve one problem on this? Because this is a little bit different. So see here, one small problem again. Problem. The shear modulus for a metal shear modulus for a metal, shear modulus for a metal but we did not finish this, I think, modulus, right? Shear modulus. So wait for some time, later we will solve this type of model. Okay, this problem we will solve later because the shear modulus we did not finish it. Okay, so one note point I will give. One note point problem we will solve later, this type of problems, whatever I was giving before some time. So one note point you write down. For isotropic substances, or for isotropic substance, shearing stress, shearing strain is equal to 2 times of longitudinal strain and bulk strain or volume strain. Okay, volume strain, another name is what? Or bulk strain, is equal to 3 times of longitudinal strain. Okay, So here we have learned this volume strain. No, another name is what? Bulk strain. Keep it in mind. Here also you can write as or bulk strain. Got it? Understood? Okay, so note down these two note points. And I am sending 2-3 questions. You just solve that. Very easy questions. Stress and strain model. Whatever we have finished till this moment of time. Just 2-3 questions I will send. Just solve that. Okay. Right. So let's stop here for today. And bye.